Yesterday was inverse trig functions. Today we're going to do derivatives of inverse trig functions. So it's just 3 more rules that you have to know. It's not concept so much today as you just got to know the rule for how to take the derivative of inverse sine. And we'll just do sine, cosine, and tangent. Beyond that, it gets a little crazy. So the derivative of inverse sine, there is a way you can come up with this, but most of the time we're just going to, this is one of those just trust me things. You don't want to see how it came about. 1 over square root 1 minus u squared du. The du thing is the chain rule. The main rule is the 1 over square root 1 minus u squared. So that's kind of tricky. That's new, different. I guess the good news is inverse cosine is similar. In fact, really similar. The only difference is it has a minus sign on it. And it turns out that that's really good news for when it comes to integration, because when it comes to working backwards, you can just pull the negative out front and you will never integrate where your answer is inverse cosine, because if you take the minus sign off, if it looks like that, it'll be inverse sine. If it looks like that, you pull the negative out and it'll also be inverse sine. That's really tomorrow. Today is just derivatives. Tomorrow we'll go backwards. And then lastly, the derivative of inverse tangent. Tangent is usually more complicated, right? Because it's sine over cosine, so it's usually more complicated in everything we do with tangent. But not today. We finally catch a break on tangent. 1 over 1 plus u squared du. There's no magic to those, you just have to know them. Just like you know the derivative of e to the x is e to the x, the derivative of x squared is 2x, the derivative of natural log is 1 over x, derivative of sine is cosine. Like all that list of derivatives that you need to know, add this to it. So let's do some examples. Y equals inverse sine of 4x. Well, can't quite get it all on the screen at once. So the derivative is 1 over square root 1 minus the argument, right? Whatever the argument is what goes in per squared, or what we square on the other side. And then the chain rule, the derivative of 4x is 4. And that's a safe stop, so you could leave it like that if you wanted to. Multiple choice, we'd clean it up a little bit. Just make sure you square the 4 and the x there. Number 2, f of x equals arctan of x cubed. Remember, arctan means the same thing as inverse tangent. So I'm looking at my derivative of inverse tangent. x cubed is the argument. So 1 over 1 plus x cubed squared times chain rule 3x squared. That's a safe stop. Multiple choice, we would clean it up a little bit. 3x squared over 1 plus. Here you go. Here's your Monday or your Thursday morning algebra review. What's x cubed squared? X to the 6th. Yes. Number 3, y equals arc cosine of x over 2 cubed. So lots of chain rule stuff going on here. What's the outermost function as we start to peel back the layers here? The 3. So I've got something cubed. So I need to follow the cube rule first, or the power rule first. So y prime. By the way, I keep intentionally switching up how I write a derivative just to make sure we remember dy dx, f prime, y prime, that's all the same stuff. So 3 times all that stuff squared. And then I'll have to chain rule off of that. Arc cosine x over 2. Now I need the derivative of, so that was the 3. Now I need the derivative of arc cosine. So I look back and it's negative 1 over square root 1 minus argument squared. And then I'm still not done because now I need to chain rule the derivative of x over 2. What's the derivative of x over 2? 1/2. It's 1/2 times x. Now, that's a perfectly legitimate safe stop, but there's a lot of algebra that can be done and sometimes is done, especially on multiple choice. So let's make sure we can get from there through the end of the problem. And the main issue, I think, is this fraction in the square root down there. Let's see. So negative 3 arc cosine x over 2 squared all over. I'm just trying to rewrite it now. I haven't really simplified anything. So that's not really even any algebra. That's just condensing. I'm not done yet, but that's just making it look nicer. You wouldn't say that's easier? I mean, in some ways, this is nicer because you can clearly see like the chain rule effects. And so, if you have a safe stop, you should leave it like that because it's easy to see that where you did the chain rule. But if we want the most condensed answer, this still isn't the most condensed answer because of that fraction in there. So, here's the trick that we're going to pull. Cosine x over 2 squared. I would like to multiply that 2 into that square root and let it cancel that 4 in the bottom. So is there a way I could write 2 as the square root of something? Because I want to be able to multiply those, and if it's not a square root, I can't multiply them. So I could replace 2 with square root of 4. And so now I can multiply that 4 into there. get that. So the fraction went away. That would be a multiple choice style answer. Again, multiple choice on the test. You can get here, can you make it the last couple of algebra steps to make it match? And I guess the good news is that you'd only need that on multiple choice, which means you'd have the answers to look at, and maybe the answers would help you figure out what had happened. Let's do one more. This one's really more about the algebra than the calculus. Y equals x times inverse sine of x plus square root of 1 minus x squared. So this is really ugly. What's it going to take? Well, there's a couple things going on here. What's going on, or what rule am I thinking about right here? X times inverse sine of x. What am I going to have to do there? If I have x times, I'm going to have to use the product rule. So I'll have f and g and f prime and g prime and putting them all together. F prime's easy. I guess g prime's not bad because there's no chain rule to it. Let's see, do I remember it from earlier? 1 over square root 1 minus x squared. Yeah, I got that right. This would be in the category of things that I have to review every year because we don't use this often enough that I have to go over it before we teach it because it's not super fresh in my brain. I guess let's finish putting that together and then we'll worry about that last piece. So y prime would be first times derivative of the second. So x over square root 1 minus x squared plus second times derivative of the first, inverse sine of x, and then plus, I need to not forget about this over here, the rest of this problem. I'm going to just rewrite that as 1 minus x squared to the 1/2. That's not a derivative yet. That's just rewriting it as a power. So that would be 1/2 1 minus x squared to the negative 1/2 times chain rule. What's the chain rule result? Careful, negative 2x. And then, if we put that down here, that'd be a safe stop. But there's some cleanup we could do. Like the 2's would cancel. The x is in top. And square root of 1 minus x squared is in the bottom. And then this is kind of a rigged problem. Because what happens? Yeah, those two things cancel out. And so we get down and the best final answer is the inverse sine of x. So it's another one where safe stop, we could have left it there, and really you could have had that as part of your safe stop as well. But multiple choice test or CalcChat, they're going to simplify. And this is one where if you were if you were lost and you were just looking at the answers, you probably wouldn't pick that one because it seems like how in the world would all that turn into that? All right, assignments page 372, so we're still in the same section. 5.6, if you're calc chatting to check. 39 to 53 odd. Well, you know what? 39 to 51 odd, because 53 is example 4. So 39 to 51 odd. And here's a hint on 51. We've done this before to make life a little easier for derivatives of natural logs. What's the property that lets me split those up and make life a little easier? You could subtract natural log of A minus natural log of B. So if you don't do that, then you'd have to do 1 over this, and then you'd have to do the quotient rule. No, split them up, and it makes life a lot easier. And the algebra on that one would be horrible, but you can save stop and hope you can follow along in calc chat to find the right answer.